My name is Warrant Officer Class 1, Bamford Richard, and this afternoon I come to you with a lesson on aircraft propeller system, specifically propellers used on an aircraft. Now, before I start with the lesson, I would like to introduce you to the types of engines the aircraft uses. One, you may have a gas turbine engine, that's a pure jet engine, which is turbojet. You may also have a turbofan engine. You may also have a turboshaft engine and then a turboprop engine. So today our lesson will be on turboprop. Turboprop because it's a turbine propeller aircraft. Now we will take the propeller section alone and then talk about it because the propeller is used to do useful job when it comes to the aircraft. Now on the slides, we see basic principles of the propeller. Now, when you talk about the propeller theory, a propeller is a rotating airfoil that consists of two or more blades. Airfoil, it is in an airfoil shape because if we relate it to the wing, which is also in an airfoil shape, you will see the wing generates what we call a lift. But because propeller is also in an airfoil shape and it rotates, the lift here is termed as thrust. So it is an airfoil shape which rotates to generate what we call thrust. The blades are attached to a central hub which is mounted on an engine crankshaft. Now, the main purpose of the propeller is to convert engine power into useful thrust. That is the main purpose of the propeller blades used on an aircraft, to convert engine power to useful thrust. Now let's talk about the parts of the aircraft. The blades have some parts, namely the leading edge, a trailing edge, the tip, the shank, the face, and then the back. So on the picture on the slides, you see the leading edge, you see the trailing edge, you see the tip, the hub is also parts, you see the shank, and then also the face and the back as is projected on the slides. Now let's come to the most important thing, how thrust is generated or developed by the propeller. How thrust is developed by the propeller. Now, basically, the propeller produces thrust by giving a momentum of a large mass of air and accelerating it rearwards. So I will make reference to Newton's first law and then the third law. Mathematically, Newton's first law states that force, which is equals to mass multiplied by acceleration. Now, if you want force, which is thrust here when it comes to propeller, then you will need mass, that is the mass of air that must be accelerated rearwards, must be accelerated in higher velocity such that when you multiply the huge amount of mass by the velocity, you get enough force. Force, which is a thrust, to accelerate the aircraft forward. In forward acceleration, that's where Newton's third law also comes in motion. To every action, there is equal and opposite reaction. Now, the equal and opposite reaction comes in here to play when that large amount of air is accelerated rearwards. That will also try to move the aircraft in a forward position. So aircraft move rearwards and then thrust move rearwards and then aircraft move in the forward position. It can be in the opposite direction as well, when the thrust is also at the forward section and then aircraft goes to reverse. Now, the amount of thrust produced largely depends on the amount of air that the propeller can move and on the amount of velocity given to the moving air, which also states that when we want to generate much thrust, then you want to accelerate enough air rearwards so that you get enough thrust. So on the slide, the picture showing is a propeller, a four-blade propeller, which you can see airflow at the front that is moving to the back of the propeller or rear. It simply means that when propeller rotates as a result of the engine turning, it blows air from the front and send it to the rear. By so doing, if the air is enough and an acceleration or the velocity is also enough, you achieve much thrust. Much thrust as in the rearward position, which will cause the whole aircraft, because the propeller is attached to the engine and is on the aircraft, the whole aircraft is moved forward by Newton's third law of motion, motion 8 principle. So basically, that is how thrust is produced by the propeller blades. Rotating the propeller will cause air to be drawn from the forward side to the rearward side. Now, the amount of air and then the velocity of air that will be drawn to the rearwards will determine the amount of thrust, and that will determine the amount of speed the aircraft too will move on ground. Of course, that is when the brakes or the aircraft brakes are off, which will cause the aircraft to move forward. Now, to gain efficiency, the propeller blades have a cross section of an airfoil shape, special airfoil shape. That is what I initially said, that because the propeller has been shaped as an airfoil, it generates lift. It generates lift. Here, we don't call it lift, but we call it thrust. So if you want to gain efficiency, that means you have to make an angle or set an angle. That an angle, as in the propeller rotating, it will generate much thrust. A lesser angle will generate lesser thrust, and then a higher angle will generate a higher thrust, as in the propeller blades angle. I'll end here and continue next time when we meet on more lessons on how thrust is generated by aircraft propeller. Thank you very much.